Okay. Okay. So good morning, good evening, everyone, depending on wherever you are. Today in our session, we would discuss about data virtualization and also how that can be utilized to simplify all your data and analytics needs, how we have done it. So about me, a brief introduction. I have spent a couple of decades in handling and heading data engineering, data management, and data science practices at top-notch organizations like Adobe Systems, Dell, and Pero Systems. Pretty much exposed to complete life cycle of the data, starting from identification to its consumption. And today I'm going to talk about how we have fixed the data and analytics challenges in our organization utilizing data virtualization. Before we start talking about the data virtualization, let me show you a quick video and we will continue our discussion post that. So as we all know and agree that if we observe carefully, we all will notice that everything around us has turned into data. Take an example of our cars, maybe watches, wearable devices, or the mobile phones, smartphones that we use. But also there are other appliances or machines and things that actually generating a constant flux of data. As a result, almost 90% of the data that we have today has been collected in last couple of years only. This flood actually is presenting its own challenges in form of volume, velocity, veracity, and variety. And I think we all are facing these challenges on a daily basis. If we talk about what scale of the data that we can think of, just to give a quick snapshot, I'm talking about the massive range that varies from a few gigabytes to a petabyte per day. That's the rate at which the smart factories or airplane are generating the data on a daily basis. Now, because of these massive data, it is creating new challenges related to data analytics that are described here in this slide, actually. So specifically, the absence of data strategy, how to handle these, huge amount of data. That's the biggest problem. Secondly, data today is not only limited to in-premise, but also it is lying on cloud and elsewhere, not only within the organization. New data sources will be keep on adding, and hence we always need a agile data strategy where we can add on, new data sources quickly. And also there is always a requirement for integration, which is data at rest and the streaming data as well. In past, we have worked and tried to address these challenges of integration through the ETL tools, right? So we have been using data stage, machine learning, ab initio, and there are a lot of like SSIS packages. There are a lot of such tools available. Historically, these processes have been used and it has worked well because most of the data sets were structured and they all were in premise. But now the whole paradigm has changed. Data is everywhere, and that's why this specific approach is not working. It started failing. Looking for the new challenges, we would need new tools and new techniques to handle them. In our specific cases, so we have data which is lying in SQL Server, MySQL, MongoDB, Oracle, Cassandra, and also some data is in PDF files. Some data is also in Excel sheets. Not every Excel has been still be converted into the core systems or the online systems. Some of the data is in premise, but there are some of the data which is in cloud. We are using AWS. We are using some of the other co-location servers as well for the data residency issues. So these are the spectrum that we had. And we were looking for a specific way how we can integrate our data. What we thought of looking at the specific need of our organization, we thought of utilizing data virtualization. Data virtualization is something that provides an architecture wherein we can create a specific data view on disparate data sources. So the data could be in cloud, data could be in your specific production application or a specific database or specific, it can be in mobile app, it can be in dashboards. We can integrate this data on the fly in form of a data view, and you can utilize this data as if they have already been integrated and we have a specific data warehouse built. The detailed architecture is a specific three-step process, which is connect, combine, and consume. In the connect layer, it is like different source that we connect the virtualization software, and it creates an abstracted data layer. You can combine them together and then expose to any consumer in form of any application or your reporting tool or visualization tool or in any form that you wanted to consume your data, right? This is how we implemented it. So in fact, it is like a four layered architecture. So it's like the base layer, and then there is a physical layer. On top of physical layer or the abstraction layer, we built a application layer, different applications. On top of the application layer, there is a interface layer, and combining them into one together has provided us a complete data view for all the application of all the departments, depending on the conditions that we have provided. Some of the common data virtualization use cases where we can use this, that is what I have mentioned. You can use it for logical data warehouse or the virtual data marts. You can also integrate some of the applications for which the database designs are not known, or the legacy applications. You can create single production view or single customer view. You can also use it for your integrating and providing your customers specific data services that they would need. So the data will always be readily available, irrespective of whether the data is at rest or it is coming on the fly. You can always integrate. Whenever the data will come, the customer will be exposed to that without even knowing the details of it. So there are 5 specific essential capabilities that data virtualization provides. So data abstraction is one, no replication, no relocation. So the specific theme is based on that the flood of data we are trying to address, and if we will still be using the old methodology or the conventional methodology, you will always be only replicating data from one place to the other and then consolidating. That's how we have been using throughout many years in past. So that is not actually solving the problem of the data, but actually it is aggravating that problem, right? You have 100 petabytes of data before already, and if you are combining it with the new data sources, again you will combine and replicate into a specific place and keep your data, curated data, for again for your warehouse or the analytic purpose. So data virtualization, the key capability is that there is no need for replicating that data and no need to relocate the data. So wherever the source the data resides on, that can be consumed from there. Then third is that you can always have a real-time information. You don't have to wait for the load to get completed, and then for next day you will have n-1 data for the analytics purposes. And then centralized metadata and security governance. So data abstraction, it provides a single virtual repository and it abstracts the data complexity. So location, format, protocol, irrespective of that, customer needs the data. We can provide the data without going into the detail, as if data is like a service. So it provides you a service-oriented architecture for all your data throughout the organization. So as I told you guys earlier, it diminishes the need and also effort of intensive ETL processes. If there is a new data source that needs to be added, we can make changes in the view instead of writing new ETL jobs. So it makes the life of the integrators really easier. It also eliminates, as I told, unnecessary data redundancy. So if you already have massive data which is stored in various sources, you don't have to replicate it again. And also, I mean, the most important thing is that it provides the data in real time to your consumers. So the data will be readily available whenever it will come in any source, depending on the condition that you have provided for your data views. The logical view of data will be able to present that to the customer within no time difference. And then self-service data service. So it facilitates all the data, internal and external. It connects the data silo. So if your organization have multiple departments, they have their own data stores or data sets. The best and easiest method is to provide a virtualized layer on top of it that will give the information on a holistic view of different departments, and it breaks the data silos, in fact. So now coming back to the example, there were some concerns when we started our data virtualization in terms of, okay, if we start using the data from the data source itself, how the query, because analytical queries are always a little heavier than the transactional ones. So how the performance, how the total subsystem will perform. So in this specific picture, if we can look here, it talks about a specific case wherein if we don't use data virtualization, right, the techniques how group by joins and unions can become a nightmare because of the number of rows. If you can see down, each source system, in our example, it passes like 593 million rows throughout the network. and then joined together and then aggregated to give the expected result, which is like very heavy on the network. If we go to the next slide, this example actually shows how aggregation push down technique minimizes the number of rows returned from each source systems. So that's the reason why it is able to improve the performance. As you can see in this picture, that the total number of rows passes through the network has now reduced to only 9 million instead of 593 in the previous slide, right? And that's a huge difference that it can make in terms of the performance. Again, there's one more technology. I mean, apart from the dynamic query optimizer and the use of massive parallel processing, with the aggregate pushdowns, that helps providing the optimum performance, which presents a very minimal difference between the logical integrated virtual data and the physically integrated. So we have measured in our specific case, and we did not find major differences in terms of the execution times. And that's when we opted for data virtualization. It helped us to cut short the time to actually integrate the data and create a data warehouse. That's like a multi-year project if you have to start everything from scratch. We were able to do this within a couple of months' time to integrate all the data for our departments and create a data abstraction layer, and also start the data visualization on top of the virtual layer. The data strategy, again, as I told, combine, connect, and consume. Within 3 months of time, we were able to start showing value back to the business in terms of the way that they were collating the data. The analysts of the business teams, who were earlier spending their time only in collecting and collating the data, seeking so many data extracts and collating them, they were actually started focusing on their real work on actually start visualizing these data and getting the decisions, getting their insights shared with their business, and take specific management decision on basis of that, and also in a timely manner. So with this, my data virtualization session is like, I would like to conclude that, and I would like to open if there is any question specific to how we have implemented or any other thing. I would like to welcome that.